In the last episode, a new task was introduced. After some clarification, the problem became clear and the department's requirements had changed. So basically, every day a supplier uploads a shipment manifest CSV with critical delivery data, but the ops team isn't notified when it arrives. As a result, they rely on manual checks or delayed communication, leading to wasted time, missed updates, and slow response to shipments. As usual, we'll start with a relatable illustration, then break it down in AWS terms, and in the next episode, we'll bring it to life with a live demo. Imagine a restaurant where customers walk in and place their orders at the counter, but there's no one there to take them. The orders pile up. The chef is in the back, completely unaware, and the other teammate responsible for checking is, let's just say, busy. When the teammate finally comes to check, there's a heap of orders waiting, customers are frustrated, and the kitchen is scrambling to catch up. Now imagine instead there was a self-service kiosk. The customer places their order, hits confirm, and instantly the chef gets notified in the kitchen. Work starts immediately. No delays, no pile-ups, no missed orders. That's exactly the problem we are solving, but in the world of logistics and cloud infrastructure. So now, a supplier drops a manifest CSV into S3. The moment that file lands, S3 detects the upload and needs to tell someone about it. It does this using a built-in feature called Event Notifications. You can find this inside your S3 bucket under the Properties tab. Once you click Create Event Notification, you get a form. In that form, you fill in the event type, which is S3:object-created:"put", meaning any new file upload, a prefix filter, so it only watches the incoming / folder, and a suffix filter, so it only cares about .csv files. Everything else that lands in that bucket, S3 ignores completely. Now, at the bottom of that form, you will notice there is a field asking for an SQS-QARN. That ARN is the address of your SQS queue. Think of it like a postbox address. You are telling S3 exactly where to drop the notification when a file lands. Now, what is SQS? Amazon SQS, Simple Queue Service, is a service that lets different parts of your system send messages to each other asynchronously. In simple terms, it's a queue, like a waiting line, for tasks. So the moment you paste that ARN and hit save, S3 and SQS are now linked. S3 knows where to send the message. SQS knows to expect it. So when the supplier uploads the manifest, S3 checks its rules, the file passes all 3 filters, and S3 immediately writes a message into that SQS queue containing the bucket name, the exact file path, and the timestamp. SQS receives it, holds it safely, and waits. So up next comes Lambda. But what is Lambda? AWS Lambda is a service that lets you run code automatically when something happens, without having to manage servers. So what role does that Lambda do here? Lambda is the brain of the pipeline. It has one job: take the raw CSV that just landed in S3, make sense of it, and turn it into something useful for the ops team. But before it can do any of that, something has to wake it up, and that something is SQS. Remember the message SQS is holding? The one S3 dropped in when the manifest landed? Lambda is connected to that queue. The moment that message appears, AWS automatically fires up the Lambda function and hands it the message. Lambda did not poll. It did not check. It was simply called the same way a chef gets called when a new order ticket arrives at the kitchen. Lambda fetches the file from S3, then does 4 things in order. Validates the columns, counts and totals the shipments, flags anything delayed, and builds the email. If the file is broken, it stops early. If everything is clean, it hands a formatted summary straight to SES, and its job is done. Every single one of those steps is written out as code inside the Lambda function. That code is what gives Lambda its instructions: what to look for, what to count, what to flag, and how to format the email. Lambda is flexible. You can write that code in whatever programming language you are comfortable with. Python, Node.js, Go, Java, and more. Don't worry, this isn't the code you'll be working with. The actual code will be shared during the demo. So Lambda has done its job, and now it hands things over to SES. SES means Simple Email Service, and that is AWS's dedicated service for sending emails. When Lambda calls SES, it builds a fully formatted email for the ops team. Here's what they see when they open it: metric cards, status badges, flagged shipments table, all built by the code inputted in the Lambda function, and then SES delivers it to the right team. And there you have it. Job done. Make sure to check out the next episode, where we'll bring everything to life in a live demo.